this topic. Sister Wheel, iHecoBet, Achilles, and FitGen, one after the other for about 10 minutes each. And this will be followed then by the Q&A session. Please enter your questions in the chat box, and please indicate also to which presentation your question is related. The session will be recorded, so you all will be able to see the presentation again after the event. And let me welcome our session speaker from the European Commission. This is Saki Gerasistavite. He obtained a PhD from Universitat de Vigo and now works as Policy and Data Officer at DG Move. Saki, welcome to the session. I look forward to your introductory remarks.
Thank you, Christoph. Good morning, everyone. Saki speaking here. So I'd like to give you a brief introduction in the context of the European Commission. Where do we stand and where do we go? So just to recall everyone, the EU is committed to become the world's first climate neutral continent by 2050, as you know, in the context of the European Green Deal. In the meantime, by 2030, following the climate target plan, which will set the course of action requires across all sectors of economy to be followed by concrete policy initiative. It will look into transport. We expect to achieve in total emission reduction target of 55% by 2030 already. So to achieve these objectives and looking particularly into transport to obtain a 90% reduction in 2050, we find that electromobility, electrification is a technology of paramount importance. In this context, I would also like to remark that the work of the Commission are to link two different goals, two different dimensions. On the one hand, the green transition, and on the other side, the digital transition. You will see today in the session that we are linking these two different goals, that now they are merging, and they represent a very, very big holistic approach. On the other side, I would like also to focus a little bit and to give you some insight when we talk about electrification and electromobility. From the Commission, we are seeing positive signs, and we have seen that, for example, the sales of electric vehicles, including plug-in hybrids, have more than tripled in this Q3 from July till September this year, which represents a 10% of all new cars in Europe were electric. This is a big jump compared around 3% that we saw in the same quarter last year. In this context, we see that the European policies have been instrumental in this regard. I'm pretty sure you all are aware, most notably, of the CO2 emission performance standards for cars and vans that have been, as I said, instrumental. But we also have other policy initiatives like the Alternative Fuels Infrastructure Directive, the Clean Vehicles Directive, that we are working, particularly in some of them in the revision, that will represent a big step forward to continue in this direction. And just to finalize, we are in the mid of a transition, in the mid of a revolution at some point, where the acceleration to achieve of a sustainable and smart mobility is more important than ever. In this context, we have today this session that represents the main ideas, the main research steps that we have to take to achieve a mass introduction of this technology. So I'm happy to be here with you. I'm all ears to listen to you and to see the great advances you are bringing us with us here today. Thank you.
Yeah, thank you very much, Saki, for the introductory remarks. And then may I ask all the speakers to turn off their cameras and to mute their microphones, because now we will be starting the presentation or the movies. First of all, thanks to all speakers of this session. So that has been a very interesting set of presentations. And may I now ask the speakers to turn their cameras back on, and also open your microphone. And the best when you answer to a question or when you have something to say, to avoid any echo from the background. So, and yeah, also Saki is back with us. Thank you. So there hasn't been too much going on in the chat, but maybe we can start with Sister Wheel. So there was one remark like, take the challenge. Increasing the size of the battery will increase the range, but also the cost. So how did you address then the cost topic in your project, Alois?
Yes, that's true. So I think the important thing is that with these compact technologies, with the in-wheel motors and the in-wheel suspension, we get this one additional degree of freedom to choose either to go for, let's say, higher cargo space or a bigger battery in our case, especially because of the cost. So this is perfectly true. We went for the bigger cargo space, and the target is to, although to achieve this higher range, but in our project by means of efficiency gains and weight reduction. So the battery will stay untouched.
Okay, thank you. And yeah, you came up with the in-wheel suspension. So can you elaborate a little bit more about the benefit of having this? Because this by nature sounds uncommon and maybe a little bit complicated. So what is the particular benefit of that, except for the additional space that you gain in the back?
I would say this is the main advantage, that we gain additional space, because of course the suspension, depending on how it's really done in the vehicle, takes quite a lot of space. So I think that's the main advantage. But although the goal is to achieve the same performance in terms of comfort and so on, damping comfort.
Mm-hmm. Okay. And did you consider combining the in-wheel motor and the in-wheel suspension at all?
Yes, let's say we tried to go for these options, but because of packaging reasons, we chose the solution to separate it on 2 axles. But let's say the ultimate goal would be to combine these 2 measures in the same wheel.
Yeah. Because I remember that in the very early discussions, this was an argument for the in-wheel suspension, because
Yes.
you can achieve a reduction of the unsprung masses in there. Yeah.
Exactly.
Okay.
Yeah, that was the primary target, but due to packaging reasons, we had to go for the second option, to separate them on the 2 axes for demonstration purposes.
Yeah. And so with the 2 in-wheel motors on the front axle, then certainly you also can perform torque vectoring. Do you do the same on the N2 vehicle on the rear axle?
Yes, exactly. We can use these technology for both vehicles, and the goal is to, for instance, also to have a kind of slip reduction, and to by that to increase the energy efficiency, and also to decrease the tire wear. So these are the 2.
Yeah. I think that's also a main advantage, that you can actively support the reduction of wheel spin or slip on the unloading wheels. Yeah. Okay.
Exactly. Tire wear then also is again a factor for total cost of ownership, and that's a advantage.
Okay. And I think we have one question going to Aitor at iHicobet. Could you please explain what you are able to remove, the gap fillers and what else?
Yeah. Thank you for the question. I think it was Olivier. Yeah, we can remove the gap filler and also part of the aluminium structure. I mean, the main reason is that we don't have a cooling plate anymore. It's not a aluminium plate. We only have some aluminium structure at the bottom of the battery pack, but the surface that it's in contact with the cell modules is not made of aluminium. It's an advanced polymer. It's a flexible cooling system made of an advanced polymer. And as it is flexible and it's pressurized directly with the coolant, it has a much better contact with the cell modules, so that we can avoid this gap filler. and as a consequence, we reduce the cost of the gap filler and the cost and the environmental impact of the aluminium structure that we are removing. We need another material that consumes much less energy to be produced, and also, of course, the cost of it's reduced, and it's one of the goals of the call of this call is to reduce the cost of the full system. So that's the main idea of the flexible cooler.
Mm-hmm. So if I understood right, you put the heat exchanger on the top of the cells in your battery pack.
At the bottom of the cell. I mean, it's at the bottom.
Okay.
Yeah, we are modifying the standard heat exchanger of our sample vehicles, which has an aluminium tray at the bottom of the battery pack, below the cells, and below the module. And we are removing this and also the material to improve the thermal contact between the heat exchanger and the tolerances that the module has. So that with that substitute heat exchanger, we increase the contact and, of course, the efficiency of the heating system.
Okay, thank you. So, with the sensors, you can then measure the entire temperature distribution in the battery and get a better idea of if there is any cell that is going to be overheated in there.
Yeah, that's right. With the fact of substituting the metallic heat exchanger by this polymer-based heat exchanger, we embed new functionalities directly in the heat exchanger. Yeah, we can monitor better not only temperature distribution between different cells, but also we add impact sensors to, for instance, to monitor if a stone or whatever hits the bottom part of the car, or another type of sensors also to have a much deeper view of the battery pack. And of course, all this data are later acquired by the rest of the solutions I mentioned in the presentation.
Okay. So what is the purpose of having this heat exchanger flexible? Will it swell when the fluid passes through this polymer system, or what is the idea behind?
The idea behind is to fit better the space. I mean, as it's flexible, we do the work of the gap filler. Let's say we can adjust much better to the spaces between cells, and the contact is much better. And I mean, it's not that it's inflating all the time. Of course, it's pressurized with the coolant with a certain pressure, so it's not modifying the vibration. But I mean, the main goal is to have a much better contact with all the surfaces that must be cooled down.
Okay. Good. So, yeah, there's another question. How much roughness of the bottom surface of battery module can the flexible cooler, I think, stand or fit without gap filler? Usually some pressure is necessary to fit.
Yeah, as I said, this flex cooler is pressurized. So yeah, this is what the main goal is of this pressure is exactly this, to overcome this roughness of the especially in the spaces between cells, because of course the cells are together, but always there is a small space. So all this roughness that the cells provide, it's overcome by the flex cooler instead of the gap filler, which is its main target.
Yeah, the flex cooler takes some function of the gap filler basically, since it inflates and then surrounds the cells at least at the bottom. Yeah, yeah.
Yeah,
okay.
That's right.
Mm-hmm. Okay, thank you.
Mm-hmm.
So let me see. Yeah, some question. I don't see any question here to Achilles in the chat, but nonetheless, let me come to Thomas. So you mentioned that you were assuming like 24 gigawatt hours energy saving annually in the years 2026 to 2030. So just for these 4 years. So that is certainly not associated with a single vehicle, but what is the kind of fleet that you were assuming, or what was the underlying assumption of the car fleet that you used to project this energy savings?
Yeah, I don't have the exact assumption in mind, but it's basically usual assumptions for the evolution of the electric fleet in Europe. Yeah, I don't have the exact numbers. We got this calculation already a while ago, and I must say, yeah, I don't have the number of vehicles in mind.
So the question is if that assumption actually was fitting then to the current, let's say, accelerated take-up of electric vehicles that we see in the market. Was if it was a rather pessimistic or an optimistic assumption that you made? Okay, thank you. Good. And so just for clarification, you mentioned the dry brake. That means that you install a brake-by-wire system instead of hydraulic actuation, is it?
Yeah, it is. Yeah.
Okay.
Yeah, so it's full by-wire braking. The brake system, it's developed by Continental. Yeah, included in their new wheel concepts.
Okay. And so how do you guarantee then the functional safety of that? I mean, this is new, so everybody might be a little bit cautious to jump on that.
Yeah, indeed. But we are performing extensive tests on the components first, and then later on subsystems, and then on the full vehicle level, including road testing. With all partners involved, and the test procedures have been defined already. They will be followed closely by Audi as well. So we'll have full check on safety, but obviously when it's a new concept, you need to go with extensive testing, but we'll do it in the project. Yeah.
Okay. The benefit of having that is that you can fully exploit then the recuperation function of the electric motors and only engage that dry brake in cases of emergency, or what is the strategy behind?
Yeah, so we have regenerative braking with this by-wire braking, and we combine it with the out-of-phase control. So in case when we have regenerative braking, if the battery is already fully charged, then we can dissipate the excess energy by operating the motors inefficiently with the out-of-phase control. But then, we guarantee that the brakes are cheaper and lighter, and
Did you develop any strategy how to brake? To brake without the dry brake when the battery is already full?
Yeah. Well, that's by dissipating energy with the electric motors that are in wheel. With the out-of-phase control, so we just operate them inefficiently. We dissipate the excess energy, and that's when the battery is full. Otherwise, we just recuperate as much as possible to charge the battery.
Okay, good. Yeah, and then for sure your Achilles project is, let's say, the mother of Evolve. Yeah.
Yeah.
So yeah, I really appreciate Stella's and Eva's engagement in organizing the work package leaderboard, the project leaderboard meetings for dissemination purposes, and keeping everybody together. So yeah, thank you for this. Very well. Then maybe FitGen. Let me check how much time is left, and we still have a good quarter of an hour. So yeah, let me. So with the 3 stops of maximum 25 minutes each, when going for 1,000 kilometers, yeah, you're kind of pursuing the same strategy as we have in Seavolver. Yeah, so welcome to the team. I like that idea. So that's but I saw that you spent quite some effort in the e-motor development, and that was really interesting. So you're employing a permanent magnet electric motor. So how did you manage to reduce the rare earth content in the magnets in some way? And how?
Thanks, Christoph. The amount of rare earth contents is not an objective of this project. We did work a lot on the design on how to best use these rare earth magnets. And our challenge in FitGen was to achieve with the current generation of state-of-the-art permanent magnet with rare earths to achieve the 5.2 kilowatt per kilogram. This was the objective of FitGen. Indeed, achieving this performance with a reduced amount of rare earths is exactly the next step.
Okay. So also from one of the pictures, I had the impression that you managed to increase the packing density of the windings quite some. So what was the approach that you took for that?
Formed Litz wire, patented by Brusa, which is the owner of the motor technology. So there are a few publications, some done within FitGen, some that were basically based on the background work done before FitGen, which demonstrate that this technology at the moment is capable of packing the largest amount of copper in the state of part. So we are pretty much confident that this with specific technology of formed Litz wire, we are hitting the state of the art as per today.
Okay. And I think there was another question in the chat.
There is a question from Jan.
Yes.
About the integrated solution, how the integrated solution helps to achieve the range target. The range target is achieved by putting together and working in synergy the different achievements that has been reached under the motor, under the cooling, and under the inverter area. So it's quite difficult to trace back to one single development that we did in FitGen, the achievement on the range target. As far as integration concerned, this of course helps in reducing weight and reducing cabling between the different components. Indeed, we have just one single pack, everything is super packed. We have basically no cabling between the different components of the axle, and this helps. But the range target is achieved, the range target of 1,000 kilometers and the distance-specific energy consumption of 120 watt-hour a kilometer, which is quite a challenging target. It's achieved by making all the technologies working in synergy. And concerning to the next question of Jan about the C rate, for me, but this is a question for all the project, in FitGen, we target 3C for recharging.
Okay. Based on NMC batteries, or which kind of batteries?
Again, the battery is not an element that we do develop in FitGen. And how do we achieve 3C from a battery side, it's a subject of other project that I coordinate. So also there, it's, and I also reply to a question that I see in the chat, which is below. The question is coming from Yazutaka. Sorry for not spelling correctly your name. Is there a special thermal management for the battery pack and for fast charging? Of course, there is, but this is not a subject of FIGEN, and we do achieve 3C by also here making a new battery technology working with a new BMS. But this is another project.
Yeah. Yeah, that's why we have this cluster of GV1 2018 projects. Yeah, so thermal management certainly is in focus in the project Selfie, for example. And yeah, so that's why we have this cluster to basically complement each other with the different focuses of the projects. Yeah, absolutely right. And there I see, so thank you, Michele, for the moment. Then I see another question actually also there for Achilles. So let's go back to Achilles. Does the dry brake system improve cost or efficiency? I think you partially answered to that. And does it need the special control strategy or work? Yeah. So most of that I believe you already answered. But if you wanted to comment in addition to that, Thomas. Thomas looks frozen. Okay. Yeah, he doesn't move at all. There's no sound from Thomas. I'm afraid his line is frozen.
Thomas, try refreshing your page.
Thank you, Verena.
Sorry for the interruption.
No, it's much appreciated. So unless no one appears like a mummy, it's fine. So now, Thomas, you're alive again. Yeah,
yeah, the connection was lost.
Yes, yes, this happens every now and then. Did you get the question, by the way?
No, I heard you were beginning to ask it, but I didn't hear it.
Okay. Well, I think in parts you already answered to that. So there was one question in the chat that I wanted to bring all the same. Does the dry brake system improve cost or efficiency, and does it need the special control strategy to work, or does it work by its own?
Yeah, it improves both cost and efficiency. So we removed actual mechanical brakes, so we reduce the cost, the weight, and improve the efficiency. And the control is developed together with the centralized computer platform. So it requires a special control because it couldn't work without the regenerative braking. It couldn't work without the new control that we're developing. And I saw another one about the ECUs, whether we consider all ECUs into one ECU for the modeling and the integration. So actually we still consider them separately, but they all interact with the central ECU and the central computer platform, where the main the control of the vehicle with torque vectoring and control of the dynamics is performed, but still we have local ECUs for the battery system, for the powertrain, for the brake system, but then everything interacts with the central ECU where the dynamics of the vehicle are controlled with the torque vectoring.
Mm-hmm. Yeah, okay, thank you. Maybe, yeah, then there is a question for Maurizio that I would like to put in the round, like as a kind of closing remark for everybody. With the last 8 minutes that we have, that should be fine if everybody takes the word for like 1.5 minutes. So anybody considering allowing a variable C rate depending on the conditions and previous life? So like charging a few times at 5C twice a year, for instance, might be acceptable if no fast charging in the rest of the year, if you just plug 230 volts for the rest of the year, maybe. Yeah. So maybe we can start with Alois.
Yeah, not in the sister wheel project, as the focus was on the, let's say, on the propulsion technologies itself, and the battery stays untouched, and the charging was not in the focus of our project. So unfortunately, I can't answer this question.
Okay. Also, not from the other projects that you might look over the across the fence into at Virtual Vehicle. Okay, good. Yeah, Aitor, how about your project? What do you think about occasional fast charging when otherwise you take your time to refill the battery? Any experience about battery degradation? You might reopen your microphone, please.
Okay, sorry. I opened and closed it. Sorry. Yeah, I mean, we are studying one of the profiles that we applied to our characterization tests. It's a fast charge. And I mean, we are looking at it from the point of view of the thermal management. Okay, more than the degradation. I mean, the objective is to reduce the degradation, but what we are studying is the heating. I mean, the cooling requirement that this profile presents to our thermal management system. Of course, yeah, I agree that we can very few times. I'm not sure if 5C, but we are considering something like, I think it was 3C of fast charging, and we are taking special care to the thermal management during this demand. The idea is to not only actively dissipate this heat generated during this fast charge, but also we are studying different alternatives to, for instance, to be prepared before a fast charge occurs, maybe cooling down the battery more than what is needed, and other different alternatives. So, yeah, I mean, there are different options to, let's say, minimize the impact of this such high currents, and give some extra functionality to the vehicle to improve the user acceptance, of course, with a fast charge.
Okay, thank you. Thomas, any opinion about this occasionally fast charging from your side?
Yeah. So yeah, with regard to Achilles, we do not work on the charger or on the actual degradation of the battery. But in general, I think it's a good idea, but it definitely requires more development, more research, and yeah, it could be the topic for another research project. But in terms of degradation, obviously, it makes sense to go with fast charging when necessary, and go with slower charging when it's possible. So you do not degrade the battery unnecessarily. But in Achilles, we did not focus on this aspect at all.
Yeah. And Michele, last word from your side.
So, grazie Maurizio for the question.
Yes.
Not in FIGEN. The answer is not in FIGEN. In FIGEN, we are trying to keep the charge as constant as possible, the C rate as constant as possible for the largest possible window. But indeed, the topic that you raise is quite relevant. I had the exact same question 3 years ago at the United Nations Electric Vehicle and Environment Group, where we were discussing this exact topic. And I replied at the time with this answer that I think is still a good answer today. We are developing this technology not for the battery of today, but for the battery of tomorrow. Most of these technologies will see light on the market by the year 2025, 2026, and they will exploit their potential, let's say, in the vicinity of 2030. So at that time, the battery technology will develop. So most likely the 3B technology for battery will exploit its potential. And at the moment, I don't recall one single scientific study which shows the changing the C rate during the life of the battery being a pro or a cons for this generation 3B battery technology. So I think that these are the research questions to be answered in other projects and maybe also in other programs, not the GV one.
Yeah, yeah. Okay, yeah. Thank you, everybody. So I think, and also thank you, Maurizio, for this nice and interesting question. And what I would like to add, if you're using a battery in the vehicle, then certainly also the instantaneous in and out of the electricity or the instantaneous energy transfer between the electric motor and the battery also ranges in sometimes in a couple of Cs. So certainly not for a long time, but these small peaks are always there. And this is also something that the battery must stand, yeah, for a long time, and which it obviously does. So yeah, I would like to thank Alois, Aitor, Thomas, and Michele again for their contributions about the projects Sister Wheel, iHicobat, Achilles, and FitGen. And to the audience, you will find the summary given by our speakers from the European Commission out there in the lobby in a minute or so. And yeah, unfortunately, there's no free food and no free drinks out there in the lobby, but free information. And so join us there, and please also step by at the booths or in the virtual exhibition. And there are chat functions where you can still ask questions to the authors and the presenters of today. So thank you also, Verena, and thanks to Lucie and Bianca for enabling this conference this way. And again, to everybody also for joining and for the discussion and for the contributions to the chat. Have a nice lunch. Enjoy your break, and see you outside in the lobby. Take care.
Thanks for the moderation.
Thank you.
Thank you.
Bye. Adios. Servus.
Bye.
Buongiorno.